Today we're going to look at intervals where a function is positive or negative. When we talk about a function being positive, we're talking about the y values. When we talk about a function being positive, okay, we're talking about y values, and for the y values to be positive, they need to be above the x-axis. Y values above the x-axis. So when we talk about where is a function negative, we're also talking about y values. Okay, so this time we're talking about y values below the x-axis. Below x-axis. Okay, so there's some things on the left that we're going to talk about real quick, and then we'll get into the graph on the right. But basically it says the graph to the right is the function f of x equals x squared minus 4. Okay, so we've seen a couple of those. It has x-intercepts at -2, 0 and 2, 0. So they're telling you that it touches the x-axis here at -2, 0 and here at +2, 0. Okay, so there's no guessing. The zeros, the x-intercepts of a function that crosses the x-axis, separate x intervals where the function is positive or negative. So those 2 points, those 2 x-intercepts, okay, remember the function is positive above the x-axis, okay, so we said positive was above and negative was below the x-axis, all right? So down below, continuing on, it says functions, and a function could be f of x equals something, or it could be y equals something. Functions are positive in quadrants 1, Q1, and Q2. All right, so let's take a look at that while we're here. So quadrant 1, where is quadrant 1? Quadrant 1 is right here, Q1, where x and y are both positive. Okay, and then it actually goes backwards, counterclockwise. This is quadrant 2 over here to the left, quadrant 3 down here in the other corner, and then quadrant 4 is over here. Okay, so we say then, so based on quadrants 1 and 2, we say that f of x is greater than 0. Okay, you can also, anytime you see f of x, you can also think of it as y. So y is greater than 0 in the intervals where the graph is above the x-axis. Remember, we talked about that up above there, above the x-axis. Okay. Likewise, functions are negative in Q3 and Q4, quadrants 3 and 4. So we would say that f of x or y is less than 0 in the intervals where the graph is below the x-axis. Okay, and that's what we set up top there as well. So what I want to do is I want to look at this parabola over here on the right, and I want to ask, where is it positive? Okay, so let's just talk about that. So that's the first one we're going to look at right here. Okay, f of x is greater than, and now it says or equal to 0 for x, and then this little symbol here means in the interval or in the set of these numbers. We'll talk about how to write that, okay? But what I'm going to do first is I'm actually going to mark those intervals. So when I see f of x greater than or equal to 0, I want to know where is it above the x-axis. So I'm going to mark, I'm going to highlight everything that's above the x-axis, all right? So I'm going to highlight this guy right here and this guy over here on the right. Those two guys are above the x-axis. And if you think about it real quick, just look at any point on that highlighted area. Okay, so I'm going to mark a couple here on the right side. There's a point. The y value there is 1. There's another point. The y value is 2. There's another point. The y value is 3. There's another point. The y value is 4. The y value is 5. The y value is 6, and so on and so on. All of those y values are positive. Okay, so basically when it says where is a function positive, okay, what they're asking for is what's the domain of that part, okay? So all of those y values are positive when x is equal to what? So pretend for a minute that the only thing we have here is this section of the graph right over here on the left. And I say, okay, guys, give me the domain of that section. Now remember, domain is left to right. So we would look at that section and we would say, okay, the graph is going up in that section, but, okay, technically the graph's going down, because remember, graphs move left to right. So as I move, as my pencil goes across the paper from left to right, that graph is actually going down from left to right, okay? It's actually going down. But I don't care about that, because if I go the other direction and I move right to left, that graph is going up now, but it's also going to the left forever and ever and ever, which means the domain of that green piece is negative infinity, okay, because it's going to go left forever, all the way up to this point right here. What's the x value at that point? It's -2. Now, how do I know if I get a bracket versus a parenthesis here? And it comes into play right here. That symbol says greater than or equal to 0. If it says equal to 0, then I include the -2. All right? Now, I have to go to the other side, the other green part of this. So now I'm over here on the right side, and I'm looking at this part, and I'm basically saying, what's the domain of that part? Well, I go over to that side. It starts at 2. It moves to the right forever and ever and ever as it goes up. Okay, so as the graph goes up like this, it's also moving to the right forever. So infinity always gets a parenthesis. The 2, because of that greater than or equal sign, that means that it gets a bracket. Okay? So what we are saying is the graph, in other words, the graph is above the x-axis, okay? So above the x-axis in the intervals moving left to right. So those two intervals that we just wrote right there, negative infinity and -2 and 2 to infinity, that graph is above the x-axis in those intervals, okay? This one's a little bit tricky, I know, so just try and stick with me. We'll keep going here. All right, the next one says, where is f of x less than 0? So where am I below? So I'm going to go back and I'm going to highlight everything that's below. You'll notice this one didn't say equal, so this time we're not going to include those. So basically what I need is I need the domain of just that yellow piece, left to right. Left side is -2, right side is +2. Because there's no equal, it says less than 0. That means I don't touch -2 and I don't touch +2. So in other words, the graph is below, okay, below the x-axis in that interval above, -2 to 2, as you move left to right. Okay? Hopefully that's making sense. We'll see some more here. So if it's not quite there yet, we'll go back and look at some more. All right. This is one of those questions that tends to pop up in other math classes. What is the average rate of change from -20 to -1, -3? Okay. So whenever you hear the word average rate of change, it just means slope. What's the slope from -20 to -1, -3? So now we're going back to Algebra 1 here for a little bit, and I'm actually going to do this. I'm going to erase my graph so that you can see a little better here what's going on. So I want the average rate of change from -20, so I'm going to mark some points on my graph here, -20 right here, to -1, -3. So here's my other point right there. I want to know the slope in there. There's two ways to do slope, okay? There's two ways to do slope. One way to do slope is this formula. Slope equals y2 minus y1 over x2 minus x1. So I'm going to go back over to my points here. I'm going to call this guy x1, y1. I'm going to call this guy x2, y2. And I'm going to plug those in. All right, so here we go. Y2, that's going to be negative 3 minus y1, which is 0, over x2, which is negative 1, minus x1, which is negative 2. So we got to be careful there. We get, what do we get on top? Negative 3 minus 0 is negative 3. On the bottom, we actually get negative 1 plus 2, which is positive 1. And so my slope here is equal to negative 3, or negative 3 over 1. Okay? It's a negative slope. That means it's dropping from the left to the right. Let's go back and look at our picture. Okay? So here, again, here's my left-hand point right here. And as I move to the right, I'm dropping down to the second point right here. And by the way, I could have counted that over 1, down 3. Okay? So this slope in here, over 1 and down 3. All right? There's my slope. Rise over run. My run going to the right is 1. My rise is a drop of 3. Okay? So that's another way to do slope. That's what it means to find the average rate of change. All right? So if you think you've got this, I would encourage you again to, turn off the video, try this one on your own, see what you can come up with here, and then turn it back on and, we'll take a look here. The first part says, where is f of x greater than 0? No equal sign here, so greater than 0. So f of x is greater than 0 here, but then it touches 0 right there. So I'm going to put a dot right there. I touch 0 there, so I'm not going to highlight that. And then it's greater than 0 over here as well. Okay? So it looks like it's greater than 0 everywhere except what? 4. X equals 4. That's where that blue dot touches, where x is equal to 4. So we could say that f of x is greater than 0, okay, for x in the set, okay, this is just a little more formal mathematics, in the set from, now again, an interval, okay, whenever we do intervals, okay, intervals is always left to right with either brackets or parentheses. So the left side of this graph, okay, if I look at the left side, where's that graph going? It's going all the way to the left. So it's going negative infinity all the way up to 4. Whoops. All the way up to positive 4. It's not going to touch negative infinity. It's not going to touch positive 4 because of that symbol that says greater than. And then it jumps to the other side of 4 and goes all the way to the right to positive infinity. That's one way that you could write that right there. Okay? So when they say intervals, okay, and most of the time when we talk about graphs being positive or negative, we're talking about intervals. So we're always pretty much going to use this notation here. Okay? The next one says, where is f of x less than 0? Well, what does less than 0 mean? That means below the x-axis, right? Below x-axis. Well, the first thing you notice is there is no part of this graph below the x-axis, so in no interval. Okay? Because it's not below the x-axis, all right? And then where is f of x equal to 0? Okay? So we talked about this notation in one of our previous warm-ups. If this is x, they want to know what's the value of x where the y value is 0. Okay? What is x when y equals 0. Okay? So if I go over to my graph here, I go to this point that I already highlighted over here. And if you look at that coordinate at 4, 0, sorry if that one's a little bit light there. But basically what we've got here is we've got the point 4, 0, 4, 0. So that means that x is equal to 4. Okay? Hopefully that one made sense. All right. All right. Next page. I would encourage you again, if you can, to turn off the video and try on your own. See if you can come up with this. So it says use the graph of g of x, and they give us this big nasty equation here, but I don't care about that because I don't have to use it. And it says to solve the inequalities, and then it says part A, where is g of x greater than 0? Greater than 0 means above the x-axis, okay? Above x-axis, all right? All right, so I need everything above. I'm going to highlight again, and I can always erase later, but so I'm going to highlight everything above. That's up here, even here. Now I touch the x-axis right there, and then I'm back above over on that side. So I need the domain of that yellow part. Okay, I need that domain of that yellow part. So here we go. The domain. So I'm going to start here. So my graph is above the x-axis after 2. So I would say 2, comma. It stays above the x-axis until it gets to positive 2. Oh, excuse me, that was negative 2. Sorry about that. Negative 2. It stays above until it gets to positive 2. Now, because the symbol is greater than, there's no equals there. That means we don't get to touch negative 2. We don't get to touch positive 2. And then it jumps over to, whoops, not sure why that's doing that today. All right, so we're going to put this little union symbol here. So we're going to include to the right side of 2, and that graph travels above the x-axis all the way up until x goes to infinity. Okay, so again, keep in mind that an interval where a graph is positive is saying, give me the domain of everything above the x-axis. Okay, where is g of x less than 0? Okay, so everything below. There's only one piece that's below, and that's this part on the left side over here. Now, again, you have to imagine as that graph goes down there, it's also moving to the left. So we would say that from negative infinity on the left side, all the way up to negative 2 on the right side. Don't touch either one of those because the symbol didn't say equal. That is the only interval. Okay, remember, this is left to right. X on the left to X on the right. Okay? And then the last one, where is g of x equal to 0? Again, we just talked about this. This is the y value. Where are my y values equal to 0? All right? So if I go back over my graph, I've already got one blue dot highlighted over there. So this is x equals negative 2. And then there's also another point at positive 2 where my y value is equal to 0. That's the point 2, 0 right there. There's your y value equal to 0. And so we would say x equals negative 2 and positive 2 right there. Okay? This one does ask for a little bit more information here. It says mark the maximum and minimum values of g on the graph. The maximum, okay, these are, there's different maxes and mins. And so when we talk about maxes and mins, we want to talk about a maximum either being an absolute max, or a relative max. An absolute max means you're absolutely the highest point on the graph. Okay? So if I look at this graph, I see that this graph on the right side, it just keeps going up and up and up. So there is no point that's absolutely the top because the points just keep going up and up and up. A relative max is where you get the hills on the graph. So if you look at the left side over here, this point right here, okay, that y value there, that is called a relative max. Relative max. Likewise, we have absolute and relative minimums. So an absolute min means, hey, I'm the lowest on the graph, but this graph just keeps going down, 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 so there is no absolute min. Relative mins happen at the valleys. These guys right here. This point at 2, 0, this is a relative min at y equals 0. Maxes and mins are usually given by their y values. Sometimes you could say, I have a relative min at x equals 2. That would be okay as well. All right, so just know the difference between the x and the y, and you'll be fine on those. Okay. And then part E says, what is the average rate of change? Okay, so there's average rate of change again, slope from 0.8 to 1.3. Okay, so I'm going to have to do some erasing here again to get this one done. So I'm going to get rid of some of this stuff in here. 0.1, 0.8 to 1.3. Okay, so I'm going to mark these points here. We'll do these in blue. There's 0.8, and there is 1.3. Now, you can count that if possible. You can use the slope formula. I'm going to do both here again one more time. Slope. Oops. Okay, so before I do this, let's do this instead. I'm going to mark these. x1, y1, x2, y2, slope. Remember the formula here. We have it on the previous page. y2, 3, minus y1, 8, over x2, 1, minus x1, 0. So this is negative 5 over positive 1, which could also be negative 5. Go back to your points. Look at the point here at 0.8. I'm going to go down 5 and over 1 to get to that next point. That's my average rate of change. Okay? All right. Last one here. Again, I would encourage you to turn off the video. Try it on your own. All right, where is r of x greater than 0? Remember, greater than 0. So all I'm going to do this time is I'm going to split the graph right where it is equal to 0. So at 3, 0, I know it's equal to 0. Hey, look at part C. Where is r of x equal to 0? At x equals 3. So I've already got that one filled in, right? So the first one, part A, says where is it greater than 0? Well, it starts to be greater than 0 at 3. And remember, because there's no equal sign up here, we're not going to include 3. That graph goes all the way to the right, okay? Because if you follow it above the x-axis, check it out, it just continues to go like this. So it's going to go from 3 to infinity. And then where is r of x less than 0? Where it's below the x-axis. Now notice, and actually this graph, if you know anything about this graph, there actually wasn't an, oh, you know what, my arrow was here. It's off a little bit. I didn't even notice that. Should have been on that graph. Not sure why that's happening. But the left side of this does not have an arrow. It actually stops right there. So I'm less than 0. I'm below the x-axis from -1 up to +3, and I don't get to touch. Oh, wait a minute. Actually, at -1, I am touching because it stops at -1, so I need a bracket right there. Okay? Mark the minimum or maximum values of r on the graph. Okay? Now, as r goes to the right, it continues to go up and up and up, so there's no max. The minimum value over here, this dude, this is a min. Is this a relative min or an absolute min? A relative min has to be at the bottom of a valley. An absolute min means it's the lowest point on the graph. So this is an absolute min. And then it asks for average rate of change from -1, -2. So -1, okay, so that's the point over here, to 8, 1. So that's way over here this time. Now again, you can count this. Okay, so I'm going to start at -2, -1. I'm going to go up 1, 2, 3. So that's up 3. And then I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8, 9. So over 9, up 3, over 9. If I simplify that, that's 1/3. And I would encourage you to do it with the slope formula as well. Okay? I'll see you in the next lesson.